All right, let's look at this example of cell phone parking where people can wait for a message for pickup. And it says here the mean, the average time of how people are waiting. And so the manager wants to know if the mean time is more than 15 minutes. And so what we are going to do is a hypothesis test. So what I would do is, and notice here the alternative is that the mean is greater than 15. So what I would do is get Excel. And so basically what we're doing here, if I can draw a normal curve, is we are saying that the mean population is 15, but the manager wants to know if it's greater than. So to do this, to get everything started, so the mean population he's saying is 15, I need to get the mean sample, which I can do with the average formula. So highlight those values. I also need the standard deviation, and I can do that with equals STDEV. This is a sample. If you have an older Excel, it's just STDEV. I highlight those values, and this gives me my standard deviation. This test was said somewhere, use a t-test statistic, which I am, and that we're going to use a significance level of 0.05. Let's kind of put this here. So my alpha is 0.05. My n, I don't need to see that anymore, is my sample size. You can see that it's just 12, but there's also a count. And so if it's numeric value, you can just use count, and then I'll count how many values. The degrees of freedom is needed because this is going to be a t-test statistic because we have such a small sample size, and the degrees of freedom equals the sample size minus 1. And I need this to find my critical value. So remember, the critical value is where we're going to cut off and say this is too far, okay, away from this mean of 15. And we can do this with a t.inv. And we're going to use this probability, but notice this is a right-tailed test. How do we know it's a right-tailed test? Because we're looking for greater than. So anytime you use a right-tailed test, you should do 1 minus the alpha. And then notice here that it wants degrees of freedom. And so I can just simply click on this cell, and this gives me my critical value. So again, remember what this value is. If I standardize this to a mean of 0, it's saying if anything is past this value, meaning if you are in this critical region based off of our data, then we are going to reject. Well, what you compare the critical value to is the test statistic. And to find the test statistic, and it might be good to actually see if they showed that here. Yeah, right here. So they're showing everything that I needed for my setup, and here's how it shows how to find the test statistic. Let's go ahead and grab that so you can see the formula. Sometimes it's kind of nice while I'm typing it in. And so this is what we're going to find. So equals, I need to put the top in parentheses. X bar is my sample mean minus my population mean divided by, put the bottom in parentheses, the standard deviation divided by the square root of the sample size. Close. Okay, so that's all I did was the difference in the sample mean, population mean, and we call the bottom the standard error, where you're taking the standard deviation divided by the square root of the sample size. And as you can see, I can get this value. So if I look to see where would this value fall, okay, so that's where I'm looking for, is this value, if I can get my mouse to work, let's get a different color, would fall definitely somewhere out here. So 2.5 0.81777. So as you can see, we are in this critical region, so we certainly would reject the null, and we would say that definitely on average, based on this one sample, I don't know how this guy got lucky, that the mean wait time is definitely over 15 minutes.